So in this video, I'm going to walk you through how to complete a few sequences and series types questions that are going to help you with the practice that you're completing today. You'll notice that the practice you're completing today has all the formulas that you'll need written across the top, as well as different sections finding different values. So if they're asking for a specific term number, that means you would be using one of the a sub n formulas, where if they're asking for a sum, whether arithmetic or geometric, you would use one of the S formulas. So taking a look at number one, the worksheet that you're going to see, you have to make the decision on whether or not something is arithmetic or geometric. So when I look at number one, we're going from 17 to 11 to 5. Things that are arithmetic have a common difference. Things that are geometric have a common ratio. So arithmetic means that we're adding or subtracting the same value every time, where geometric means that we're multiplying by the same value every time. So I can see that as I move from right to left, we are subtracting 6 every time. So this means that that sequence is arithmetic. They then want me to find the 15th term. So we're going to find a sub 15. When I look at my formulas across the top, the one that we use for an arithmetic sequence is the first one, where the first term is 17 plus 15 minus 1. So whatever that subscript is here attached to the a, that's your n value. So 15 minus 1 times our common difference of negative 6. And then I'm just plugging this into my calculator. So when I do that, 17 plus 15 minus 1 times negative 6, I get negative 67. So negative 67 means that if I were to keep going from term to term in my arithmetic sequence, going down by 6 every time, the 15th one would be negative 67. Moving on to question 2, this one's a little bit more specific in what it's asking us to do. It says find n in the geometric sequence below, given that we're following the sequence 3, 6, 12, and a sub n is 3072. So when we're talking about geometric sequence, we're using this formula, a sub n equals a sub 1 times r to the n minus 1, which I'll go ahead and write here. So we know everything but n, which is what we're going to solve for. So I'm going to set it up over here. 3072 equals a sub 1, which is 3, times our common ratio 2, because we're multiplying by 2 every time to get to the next value. And again, I can tell that this is geometric because we're multiplying by something. 3 plus 3 is 6, but this next value would have to be 9 if it's arithmetic. So that's another way we can tell. And then to the n minus 1 power. From here, I'm going to divide both sides by 3. So 3072 divided by 3 gives me 1024 equals 2 to the n minus 1. When we were in class earlier in the week, I gave you 2 options to solve this one. I'm going to show you them again today. Option 1 is to get like bases. So I could keep typing into my calculator 2 to some power that's eventually going to give me 1024. So if I keep going, 2 to the 10th is 1024. And now that I have the bases the same, I can get rid of them, set my exponents equal, add 1, so n is 11. So that would tell me that 3072 would be the 11th term in the sequence if I kept multiplying by 2. Option 2 is to use a log. So if we have 1024 equals 2 to the n minus 1, I could change this to log form, where my base is 2. The other 2 values will switch, so 1024 goes next, and it's equal to n minus 1. When I evaluate this log, I could type it in as log 1024 divided by log 2, and it's still equal to n minus 1. Log 1024 divided by log 2 is 10. And again, if 10 equals n minus 1, and I add 1, n is again 11. So those couple of questions on today's review, you have some options on. And the very last question that we are doing is to find the sum or evaluate the series described. So again, as we decide what is arithmetic and what is geometric, we're looking, are we multiplying by something or are we adding something every time? So I can tell that as we go from term to term, we are multiplying by 4 every time. So our common ratio is 4. So if we're doing something that is geometric and we're finding the sum, I am using this formula here, where S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. I'll go ahead and rewrite that here. So again, a sub 1, we have been writing it with this bigger set of parentheses, but either way works the same. We'll notice that for a geometric series, we only need to know the first term, the common ratio, and what n is equal to. Where if it were an arithmetic series, we would first have to find the nth term and then plug that in to find the sum of n terms. So this way I think is a little bit easier if we're doing a series, although really we're just plugging stuff into our calculator. So we're going to find the sum of the first 6 terms in that sequence. So first term is 2 times 1 minus the rate to the n power over 1 minus the rate. My suggestion to you is that you type in the numerator first and then simplify the rest. So if I type into my calculator 1 minus 4 to the 6th power, I get negative 4,095. And I'm going to divide that by negative 3. 1 minus 4 is negative 3. And then the rest of this, I can just type in one step in my calculator. So 2 parentheses, negative 4,095 divided by negative 3. And I get 2,730. So that value means that if I were to take the first 6 terms in this series, I would get 2,730. The rest of the time is yours to work on the practice worksheet. It is due Monday if you do not finish it in class.